Hi, everybody. Good afternoon to everyone at the Santa Fe Chamber Music Festival who worked to make space for music and cognitive science at noontime over the course of this summer. This is clearly a very special, charmed organization, and I'm grateful to be part of it for an afternoon here in this beautiful place. When we hear a concert like we did last night, by show of hands, who was here last night? It was truly so special, where every note is so riveting. And by the way, if you weren't here last night, you could come tonight, and you'll know why I'm so excited about it. So when you have the kind of experience that I had last night, it raises a host of questions. What makes music so powerful? Why can a 2-hour concert feel like 15 minutes? Why is it that the Shostakovich Trio is as moving, if not more, the 20th time I've heard it, as on the first? I'm not going to pretend like science can get us all the way to an answer, but it can put forward some insights that help us think about all these questions more deeply. When we try to introspect about what makes music listening different than listening to speech, it can be hard to think systematically because we end up thinking about something like the violin part in the concert last night, and that's just a fundamentally different beast than the words I'm saying to you now. They're just made up of different kinds of sounds. To try to isolate what's really different about music listening, try focusing closely on these sounds. I'm going to play you a spoken utterance, then repeat a bit of it a number of times. Then we're going to go back and replay the initial utterance you heard. Okay.
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely as to seem quite impossible. But they sometimes behave so strangely, 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 so strangely, so strangely, so strangely, so strangely.
Okay, let's try it one more time. This is just the original utterance you heard the first time.
The sounds as they appear to you are not only different from those that are really present, but they sometimes behave so strangely as to seem quite impossible.
For around 85% of you, if research is any indication, what initially sounded like speech came to sound like music after repetition. Can you raise your hand if you had that experience? So what's really useful about this illusion from a research perspective is that it holds the acoustic signal fixed. So I played you the same exact sound file the first time and the second time. So what changed was in the perceptual apparatus you're bringing to that acoustic signal. And that means we can now isolate something about what's different when you listen musically, where it's not the sounds themselves that are changing. And what I love about it is it not only enables me to just kind of think about what feels different and seems different when I'm hearing it as music versus when I hear it as speech, but then we can go in and actually measure perceptual tendencies that change when people are hearing it as music versus when they're hearing it as speech. For example, we find that if we nudge around the syllables slightly in time, it's much more detectable when people are listening to it as music than when they're listening to it as speech. So when people are listening musically, they're a lot more attuned to temporal regularity and more sensitive to deviations from it. And you can think back to the concert last night and all the ways that expressive micro-timing, so subtle things about tens and hundreds of milliseconds that were slightly different from notation that came across as so gripping, that part of musical listening is being very tuned into that kind of thing. Another issue this illusion raises is the role of repetition. And this is a topic I've been interested in for the past 2 decades. When we heard that transformation from speech to song, the intervening force was really repetition. It was pushing the sound from speech into music. And overall, if you just tally up patterns, you'll find that music is characterized by far more repetition than speech. right? So if I got up here and now just repeated the first half of my talk to you again, that'd be pretty annoying. But people say encore all the time and want to hear people play something again. And it's not just within piece repetition, like you'd get if you turned on a song on the radio and you hear the chorus coming back again and again. You can also think of the most complicated, repetition-avoiding piece you know, and if you love it, you've probably listened to it multiple times, right? So it's not only repetition within the music itself, but also in the way that we encounter music and go back again and again to the music that we love. Repetition is one way that music draws us in and becomes participatory, even if we aren't overtly joining in, so we're sitting passively, apparently passively in the audience. Repetition allows us to do things like sing along in our heads, really predict what's going to come next. And indeed, when music gets stuck in our head later, maybe this happened to you after the concert, in the form of an earworm, that the way that that memory tends to appear is in repetitive form. It tends to have a little bit of a melody that repeats again and again in your head. So this is another way that repetition is just kind of inherently captivating aspect of music. And if we return to our comparison case of speech for a moment and think about it in terms of repetition, the form of speech that is perhaps the most repetitive and thus the most music-like, I'm trying to convince you of on the last slide or two, is the kind we fall into when we're speaking with babies. You know what I'm talking about, right? We've all done this. I thought I wouldn't do it with my children because it just seemed kind of cloying, but babies like it so much if you talk to them that way. And it's so satisfying how they respond. So quite naturally, people adjust their speech in the following ways when they're talking to tiny creatures. Become more repetitive, slow their speech down, raise their pitch of their speech, and use more exaggerated pitch contours, more melodic kind of arched pitch phrasing when they're speaking to infants. And this does not seem to be an arbitrary byproduct of one specific culture. One study built a corpus of over 1,500 recordings of speech and song that were either infant or adult directed. So people communicating with babies or people communicating with adults via speech or song from over 400 individual speakers and singers living in over 20 different societies, ranging from urban to rural to small scale, speaking many different languages. Okay, so this is really looking at how this behavior emerges and translates across all these different kinds of settings. And basically what you see here, the distribution, so the y-axis here is the percent of people who were now played any of these recordings and thought that it was a communication directed toward a baby. Okay, the higher up it is, the more people thought that was something that was communicated to a baby. And the lower down, the more people thought it was communicated to an adult. And the blue distributions are for infant-directed song and infant-directed speech. So these are cases where the speaker or the singer from any of these different languages was communicating with a baby, directing their communication to an infant. And you can see that that comes across even when people don't speak the language. It's really clear when someone is communicating, trying to communicate with an infant. On the other hand, the red distributions, the one on the left is for adult-directed song, and the one on the right is for adult-directed speech. So when people are speaking to a fellow adult, that comes across pretty clearly as adult-directed. However, when adults are singing to another adult, this occupies some ambiguous terrain where it sounds like maybe it's some communication that's directed to a baby. And this is just highlighting the way that infant-directed speech really borrows from some musical attributes, and there's just a big connection between that form of communication and what we think about as music. Because the thing is, it's not just repetition that infant-directed speech and music have in common. In fact, all of the characteristics I listed drive infant-directed speech further in the direction of music. So a large cross-cultural study, again, across many, many languages, found that music has slower pitch transitions, tends to be higher in pitch overall, and features more repetition and clearer pitch contours than speech, just like infant-directed speech. So you see an example here from this study, just from one participant, but there were tons of people from all kinds of language backgrounds. And basically, you can just see a spectrogram down on the bottom of speech. And then as you progress towards the spectrogram on the top, we get to sung speech and then to instrumental music. And you can just see how the pitches are elongated and removed. The pitch transitions are slower, the contour is clearer. And so there is this really interesting continuum from speech to music that enables us to ask a lot of questions in tractable ways in a lab about how music ends up captivating. And in a way, that's exactly what we're doing when we're trying to speak with babies in this form. We're trying to captivate them and hold their attention, right? And so at the very earliest stage of life, when we're trying to do this, we're musicifying our sounds. It's just something that happens. And the fact that this is so pervasive across cultures leads people to speculate about music's evolutionary origins. One of the most influential and widely held current theories of the origins of music explores its role in social bonding. The idea is that across evolutionary history, the capacity to make music conferred a selective advantage by facilitating connections between people. So one reason we get these reliable music-y characteristics in interactions with infants is that these features actually serve a captivating connecting role. And at the larger group level, moving and listening together in time creates more cohesion. There's a concept that people use sometimes called, that comes from Ian Cross, called floating intentionality. And the idea is that when you're listening to music with a big group of people, like in this hall together, it feels like it's about something. So its intentionality or its aboutness is very strong. But what if we got down to it, into the specifics of talking about it, maybe we wouldn't quite agree, but it kind of feels like we agree in a group setting, and that's one of music's kind of powerful, the ways it's a powerful agent of connection. This may be, this kind of advantage I'm trying to postulate here about music and connection and social bonding is a little different than the kind of advantage you might think about when it comes to music. You might think about something like I've displayed here, which is the infamous Mozart effect. Who's heard of the Mozart effect? Okay, so this started with a paper in Nature in the early 90s that showed that college students performed better on a spatial reasoning task, like this one over here, if they'd listened to a Mozart 2 piano sonata immediately before they took that test. And what's interesting is there weren't any babies in this test. Did you think, if you didn't know the paper, you probably thought there were babies, didn't you? Because it just fell into the popular imagination in such a strong way because there was already a presumption about, the kind of good this music could do and this feeling that it had something to do with cognitive abilities. And in fact, in Florida, the state legislature proposed legislation that daycares, to maintain their accreditation, needed to play classical music for a certain amount of time to their charge every day. And the governor of Georgia allocated funding in the state budget to give CDs of Mozart to every new mother in the state so they could raise brilliant little Georgians, which is all awesome, and I'm like, that all sounds great. But this is a claim, I just want to highlight the difference between the claim that I was making on the previous slides, that music is doing something about affiliation and connection, and this claim that music is doing something really cognitive. And now, I want to show you that if you think about the control that was used in that original study, not only was it not babies, but furthermore, the college students, they either heard a Mozart 2 piano sonata before they took the test, or silence. And so it's just inherently more arousing to listen to some music before you take a test than sit in silence. And so subsequent efforts to replicate and extend this finding showed that it wasn't something magical about Mozart. You could listen to any kind of mildly quick-tempoed music and be in a more a higher arousal state and score better on this spatial reasoning task. In fact, you could just walk on a treadmill, and that was the same. So sometimes things that we think are purely cognitive are really affective, right? Arousal is an affective dimension. It's something about how we're orienting in a feeling way to the world, less in this kind of reasoned way. And that's important to keep in mind when we think about music's ability to captivate. I have a couple of favorite examples of music's capacity to really draw us in as if we're participating, even if we aren't really on stage. And I'm just going to show you a clip or two here. Who among us has not felt it that way while listening? Or these kids when their dad starts to play the guitar. Check this out.
Hi, August 6, 2012. Daddy's gonna play them a little song while they're eating their peas.
You girls ready?
So note the core role of movement in both these clips that I've just shown you. The relationship between the auditory and the motor system is special. Even when you're sitting still, if you're listening to music with a beat, motor areas of the brain come online. This is one reason that even passive listening can feel so participatory and consuming. And a natural next question that emerges is, how unique is this to humans? And one way researchers get a handle on this is by comparative research with other species. Video of this cockatoo stunned a standing room only hall at a conference in my field about 15 years ago. And this was the first non-human animal shown to synchronize to a beat. I'm just going to show you some evidence, see what you think. Okay, we're going to make it a little faster and see if Snowball can keep up.
Let's do it. Come on. Yes, you do it.
I think it's safe to say that's the first time the Backstreet Boys have been played on the stage of the Santa Fe Chamber Music Festival. Since the establishment of this finding with this cockatoo Snowball, several other animals have proven the ability to do this with a lot of training, including a sea lion. Those videos are also adorable if you want to do some Googling later. But really, a surprising dearth of species. And it's almost never natural, but it's after extensive training. And furthermore, when animals are capable of being trained to synchronize to a beat, it's normally reactive rather than proactive. So when we're synchronizing with a beat, so if somebody asks me to tap along, for example, I'll tap slightly before, and that's correct. That's what being in sync is. It's just to be like slightly before. Whereas when animals are trained to do it, they normally respond right after the beat. So it feels like it's a different kind of mechanism. And furthermore, just this very natural, joyful way, as Ani Patel puts it, that humans seem to synchronize to a beat seems at minimum very rare elsewhere in the animal world. Okay. So these capacities that people doing science about music are discovering also have very real clinical implications. So, for example, people with Parkinson's experience trouble with their gait, and there's an intervention known as rhythmic auditory stimulation that takes advantage of these tight auditory motor connections to use music to improve the speed and cadence and symmetry and stride length of gait. So I'll show you an example of gait before listening to music and then while listening to music. So there's more kind of hesitancy and shuffling, and then with music. Yeah, so some of these findings are, to me, inherently interesting because of what they tell us about how we are musical beings, but the applications are also incredibly interesting, and there's a large consortium and initiative of people right now across medicine and in academic research to try to really understand how we can best move these kinds of interventions forward. Music's capacity to cue synchronized movement, which I think I've just shown a demonstration of, is also an element that helps it facilitate social connectedness, which we were kind of arguing might be one of music's origins. And here's an experiment supporting that point from Laura Sorelli. We're going to see 14-month-olds. They're strapped in a front carrier looking out at an experimenter, and they're either being bounced in sync with the experimenter or out of sync from the experimenter. And once they're finished doing that, the experimenter pretends to drop something and need help. And researchers are now going to measure the toddler's helping behaviors as a function of whether they had been bounced in synchrony or not. Okay? So let's take a look.
There. Oh, no. Oopsie. Uh-oh. No. Uh-oh.
So helpful. Peace out, lady. And this is not a one-off study. I mean, this feels like an extraordinary claim, right? Because what would we want more of in our society right now than connection and people understanding and helping each other? And, here we're saying it's not some magic drug or something. It's, simply moving to music together, right? Which it just feels like a really big claim to be making. And when there's a really big claim, it feels like you want a lot of converging evidence. And that evidence really does exist here. So I'll just give you another example of a study with older kids where they participated with a friend. So now it's about connection between the two kids that are in the image on the left. And they're being led around this so-called pond that's like a rug in the middle of a room, and they're playing a pretend game. And the pretend game can either only involve spoken communication, or it can involve synchronized movement and using the toy that they're holding as a drum. So there's a music-y play condition and a non-music-y play condition. And then, like in the study we just saw, there's a next phase where these same two kids are given this whole apparatus to play together, and it's kind of cruel because it's rigged so that it's going to break, and one kid's marbles are all going to fall out, and then they can measure how frequently the other kid helps, or whether they keep playing with the awesome thing by themselves and just leave the other one hanging. And here too, even at an older age, we see that if they had played a music-y game, moved in synchrony together, you'd see more helping behaviors in subsequent interaction. So really powerful converging evidence about music's role in pro-social behavior. And part of all of this is that music is fundamentally social to us from our earliest stages of development. So in one study, they took 5-month-old babies, and over the course of a week or so, had either their parent sing them a song across the course of that week, or they popped up on Zoom and saw a stranger sing that song to them virtually over the course of the week, or they had a little toy that played the song for them over the course of a week. And then they had no exposure to this song for 8 more months. At that point, researchers took that same song, or a highly similar one, and played it for the babies. And babies who are now older, they're now quasi-toddlers, and they preferred the song that was familiar to them only if they'd heard it 8 months ago, across the course of that week, sung by their parent in person. So they're really tracking that relationship in the sound, and it's just not the same if they're not hearing it in a highly social setting. All right, let's listen to some music for, I think it's that time. We want to really listen to something lovely. So I'm going to play you the same song, the same piece, but I'm going to play it in performance A and performance B of this excerpt. And I would like you all to think while you're listening, to just introspect about your own preferences. Which performance do you like better, why, that kind of thing, okay? So let's hear performance A. I teach a class called Music Cognition to 170 students, and I do this on the first day with them. I ask them which performance they liked better, performance A or performance B, and usually something like 70% of them pick performance B. Okay, so I make them raise their hand, and then I let them go on for a ludicrously long time about why they liked that one better. So they'll be like, oh, the dynamics were more expressive, the micro timing was more subtle, that one was so schmaltzy, this one was so honest, right? They just really go to town with it. And bear in mind, this is my first contact with these students who I'm gonna be with all semester. And after I've hung them out to dry that way, I reveal that it was the same performance by the same. And you just have to trust me because you couldn't hear it here, but you could also rig this up for yourself at home. Really, it sounds different the second time. It really does. And the whole point of this is that when we first try to understand things about how music comes to be so powerful, my first instinct, especially as a conservatory-trained pianist, is to just look at the notes, right, and time them, right? It's in the sound. And I love this example because it shows that, yes, the sound and the notes are important, but there are other factors about context and experience that are having a really huge impact as well. Although then at the end of the semester, when I ask students what they learned in the class, they'll say things like, never trust Professor Margulis. And there's another great example of the role of context in musical experience, which was the case of Joshua Bell in the DC Metro. Do you all know about this? Where there was a Washington Post reporter who had him play in the subway at rush hour, kind of incognito. And there's a really depressing time-lapse video you can watch of people, not caring. I think he made like $33 or something like that. And the point here, I think, that's really interesting is that, ostensibly it's the same sounds that you might encounter on stage here. But when the context or the kind of setup isn't right for you to be ready to receive that powerful experience isn't happening. So it's almost connects to ritual in some way, and I should say that there are languages in which there is not a word for music separate from ritual, where that is a completely connected, not a divorceable concept. And that when we think about music and what it's doing, that it's not a bad thing to think about context. It's very real in terms of how it's playing into the kinds of listening experiences that people can have. We could take a lesson, in fact, from some research on wine. This is a study where, this would be a great study to participate in. People were put in an MRI scanner. Okay, that's not that fun. It's pretty loud and claustrophobic. But they did get to sip wine through a plastic MRI-safe straw and saw on a screen displayed in front of them the price of the wine. So they could be told that it was a $10 bottle of wine or it was a $90 bottle of wine. And of course, psychologists, it's a big lie, it's the same wine, right? But you could nevertheless show that when people thought they were drinking a $90 bottle of wine, reward circuitry was active in a way that it was not when the same wine was presented as a $10 bottle. I view this really as a way of simulating the effect of context, right? Because hearing Joshua Bell here versus hearing him in the metro kind of stands in for, a $90, $10 bottle maybe, right? Something around those lines. So we wanted to simulate that in a laboratory setting. And we did it in a really simplistic way. Before we played people recordings, we said, this is a world-renowned pianist. And we played it. Or we said, this is a conservatory student of piano. And then played them the excerpt. Not only did people report liking the excerpts more if they thought they were played by a world-renowned professional, but this is the key finding that was really interesting to us. Unlike wine, where you sip it and that takes something on the order of a few seconds, the excerpts we played people were quite long. They were longer than a minute, so long compared to a sip of wine. And you would think that that's enough time for the actual characteristics of the stimulus, of the sound, to kind of overtake whatever bias you had presented people at the beginning in terms of information about whether it was a world-renowned professional or a conservatory student. But that isn't what we saw. We saw activity in reward centers increase across the first half minute of engagement with the music and then stay there. It did not decrease over that 70-second period if people thought they were listening to a world-renowned professional. Now, there were some people who were able to resist the urge of the bias. So people who said, hey, I'm onto you, and what you are saying as a conservatory student of piano actually sounds pretty great. And those people, unlike other participants, had activation in self-control executive function area. So the idea is you had to work to get past the bias to really clue into what was happening in the sound itself. And this is all just to say that there's some alchemy that, this is obviously a crude approximation by just, telling people it's a professional or a student, but there are all kinds of culturally and context-embedded signals about what's happening in music that are important to how we experience it. And in fact, did you know, this might make you feel, this is a statistic that makes me feel better, that somewhere between a third to a half of most people's day is spent in some kind of mind wandering? Did you know that? And furthermore, people spend about 15 to 20% of their day listening to music, according to our best estimates. So if you just kind of think about this, there's some significant overlap here, right, between mind wandering and music listening, just in terms of moments in percentage of the day that this is happening. And I want to, before I go into this, tell you that I think that mind wandering is great, and there's a lot of good science explaining why it's really important and why it's a problem that we do so little of it now, because we can always stick our face in a phone and not let our mind wander. Because when people don't have a stimulus right in front of them and their kind of mind veers a little bit, this network called the default mode comes online, and you end up kind of constructing scenes of what might happen in the future, what remembering things, autobiographical memories that happened to you in the past, and those functions end up being really important. And so we did a study where we played people excerpts of music in 3 different genres, either classical, electronic, or pop, and we just asked them to tell us about the thoughts they had. That's all. And the most common, the top bars here, are music-related thoughts, right? That's like the kind of thought, how is she doing that on the violin? That's incredible, or right? But the next 2 most common, if you sum them together, are in fact more frequent than a thought that's directly about the music, and that is imagining a fictional story or remembering some kind of media thing you've seen. And so this is a very, very common thing that happens across multiple genres, not just classical. So I'm going to play you an example now that we played to a bunch of people. Now, these were students between the ages of 18 and 22, so you can put yourself in that mindset, or just think, let's see if we can make this excerpt work. And the idea is just to listen and let your mind wander a little and see where it might go. Okay. If you're anything like the students in our study, you might have pictured something like this. Does this happen for anybody? Anybody? Okay. So this excerpt itself has never been used in a Tom and Jerry episode, but look at these verbatim responses. I know they're small, so I'm going to read a couple to you. These are people that were taking part in this study by themselves in a sound-attenuated booth. So they weren't, this is just their free response description of what they imagine. So they'll say things like a mouse scurrying around, a mouse doing his own thing, and then a cat chasing him, Tom and Jerry, cartoon mouse sneaking around. Sometimes it seemed like somebody would be original. For example, this response, the music reminded me of the movie Cinderella, specifically the scene where the mice are running away from the big fluffy cat, right? It's very concrete about cat and mice. So there's this kind of semantic dimension coming across that seems to be shared by a number of individuals. And this is obviously not some kind of universal association across all times and places. In fact, this excerpt comes from Liszt's Faust Symphony, the movement called Mephistopheles. So, if you went back to 1857, people might have been imagining something like this, listening to the same excerpt. So the idea is that there are these stable associational networks that can arise contingently, but have enough breadth and stability to be pretty interesting and to really shape how music can do what it does. So what I'm going to try to claim to you now for the next couple of slides is that sometimes when you're listening to music, you think you're having your own personal idiosyncratic thoughts, but actually some of what feels very idiosyncratic is actually a response to these currents that are activated by circulating musical patterns that carry the residue of all kinds of contexts that those musical patterns have circulated in previously. So what feels like your internal world is actually being structured externally. And this plugs into all kinds of interesting lines of work in the humanities. So music's a really fruitful place to pick up on these kinds of distributed currents, because as I said, we got a lot of spontaneous thought throughout the day, a lot of music listening, some of that's gonna overlap. And what I'm gonna particularly focus on now within that overlap are these fictional stories that people imagine in response to music. You saw that the Tom and Jerry Association depended a lot on media. So we were interested in working across communities with different kinds of media exposure so that we could ascertain the role that that was playing. So we did some research in 2 college towns in the US Midwest and a village in rural China called Dimen, where people speak Dong. And we used 1-minute excerpts of Western art music and Chinese art music. And the reason we selected those stimuli was because people in our participant pool in the US were not people who listened to this music voluntarily. It just kind of seeped, familiarity with it seeped in across their environment through TV shows and various kinds of experiences, okay? Similarly, the participants in Dimen do not listen to Chinese art music, but it had kind of come through experiences in television and so forth that they had had. So it's similarly kind of not the music of choice of these groups, but is music that they have some kind of peripheral familiarity with. And the first thing to note is that people imagine stories more to excerpts that they enjoy. So this is a very kind of natural, pleasurable response to music across both of these cultures. But what's cool that we were able to do only because we are in the 2020s is really analyze these free response descriptions. So many times in the history of music perception, we've had to use tasks that are like beep, beep, boop, or beep, 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 and respond to those, right? But here, we can just play people full-blown excerpts of music and ask them to freely describe for us what they imagined while they were listening. And then we can use tools that exist to look at the semantic similarity between those descriptions. So I'm going to show you a representation here of people's responses in a 2-dimensional semantic space. Now, the semantic space that we were really using had over 300 dimensions, so we've just been compressed here into 2 dimensions so that we can visualize it. But remember that behind these points are just completely free response descriptions of stories people imagined while listening to music. And basically the A's, so these big colorful letter A's, those are participants in Arkansas. And the M's are people in Michigan, and the D's are people in Dimen. Okay, so the first thing you're noticing is that people in Dimen are imagining overall different stories than people in Arkansas and Michigan. But then if you look in a closer way, you'll see that the black letters are excerpts. They're the musical pieces. So C16 is like Chinese excerpt number 16, or W9 is Western excerpt number 9. And what we're plotting here, every dot, like every A, can you see A, C16 right there, M, C16? A, C16 means all the stories people gave us to that excerpt, C16, in Arkansas. That's what that point represents, the semantic commonality across all of those stories. And what you can see is that between people in Arkansas and people in Michigan, who certainly could not be conferring about their responses because they live several states away, and this was just a random experiment they were participating in as for college credit, that the stories they're freely imagining to these excerpts that they've never heard previously are so similar as to overlap sometimes in semantic space, like for C16 or for W9. So the point to really take from the this image here is how similar the imaginings are that people are spontaneously having in response to music that they've never heard before. But this is not conveying across culture. Would you like to hear? You might be thinking, what does it mean to not convey? What could that be like? So I'm going to play you a short example of that, okay? Here is a stimulus that engendered very different responses culturally. Okay, people in Arkansas and Michigan thought someone was going to murder them. So this seems like an atonality response. So they can't get past the fact that it's not tonal, and that is just all they can really hear in the excerpt, right? Whereas people in Demon seem to care less that it's atonal and be able to cue into other aspects of the sound, like the fact that it's moving back and forth between a high and a low register, or some of the notes are really short. And it's easy to see how that could read as playful, right? So we're seeing a stable kind of set of stories in Demon in response to this excerpt, that it's like playing outside, playing games with friends, and a stable set of stories to this excerpt in Arkansas and Michigan, that you're at home alone with someone trying to murder you. And that's what I mean by these stable networks that emerge but are not universal, right? So there is this rich semantic dimension, but it's not a kind of one-to-one forever correspondence. We've shown this also for autobiographical memories. I'm going to go quickly through these slides now so we can talk more about them in the Q&A if you're interested. But memories cluster according to genre, so the kinds of things people remember to a country music song tend to be more similar to each other than something prompted by a pop song. And same thing if we just look at thoughts. So we also have a study where people just describe the spontaneous thoughts they were having to music, and that also clustered by genre. So you can really, if you use music to feel better, you're feeling sad, and the music makes you feel better, you're already kind of naturally using this. You're using music to kind of shape your spontaneous thoughts. And we can study this dynamically and see how this is happening moment by moment across time. And then we're also able, because now we have kind of a ground truth for what people are imagining when they're listening to the sets of excerpts that we've studied, we could bring people into an MRI scanner, either play them a musical excerpt that we know tends to prompt a particular story, like let's say a sun rising over a meadow and little creatures starting to frolic, or we could have someone verbally recount that same story. And then we can just compare what happens in the brain in these two conditions when the speech and the music story are matched versus when they're different. And now, instead of the activation we normally see in music studies, where we see a lot of auditory regions, we see motor areas like we talked about earlier, but now we see default mode, these higher order areas where there's distinct patterns for particular excerpts. So one excerpt across individuals engages a particular pattern of activation in the default mode, and another excerpt a different pattern. Okay, so we're really kind of seeing these stories form. And so across all of these studies that I've talked about today, here are the things that I'd really like to leave you with. When we've thought about music appreciation, music enjoyment. So this is a kind of big review paper where we think about all the different approaches to that. One goes through structure, thinking about what's in the music and how that's affecting response. There's a whole bunch of work on that. And then there's work on the self side, so the way that you might have personal memories for the particular sounds that you're hearing, like a Proustian Madeleine, they're playing our song kind of response. But that there's also this role of source sensitivity, which is everything you know about the context, who made the music, why, how you relate to them, all this kind of social dimensions. So bringing those together, we want to think about the special role of repetition in music, and that can help us think about why music is so powerful. And just attend to the way that music has important social functions, even when we might not realize it. Context does matter, and that's okay. Music can choreograph our imagination, and that's part of how music can elicit such strong emotional responses. I want to thank you all for being here, and our funders, and everyone in the Music Cognition Lab at Princeton who've been really instrumental to all the research I talked about today. Thank you.
How long have you guys been doing this kind of science with music?
That's such a great question. You can go back and find people doing what we might now call the science of music for a really long time. Like, think about Plato's Republic, right? Do you remember the section where he's prescribing certain modes, like don't listen to this one, that's bad, right? That is a sort of theory about music and listening response. But the contemporary era, if we think about it defined by the society that exists of scholars doing this, the journal and everything. This was really founded in the 1980s by Diana Deutsch and Carol Krumhansel, and it had really grown out of the cognitive science of language, which, if you think about at that time, think about Marvin Minsky, right? And thinking about computers and how they can understand language, like the early days of what we now see in machine learning and artificial intelligence and so forth. And so people were really entranced by what could you do if you took these models and study designs that had been developed to address language and just shifted over and used them to address music. So lots of the early work here has kind of some blinders on because it's just looking at all the aspects of music that are language-like. And it took some time for music to kind of get out its own feet. It used to be, one of my colleagues always says, who's older, used to say that when he applied for grants to study music, he had to say he was studying complex non-linguistic auditory processing. And it just took some time for music to be a viable, for there to be enough cool stuff happening that was music specific, that the discipline kind of coalesced. And that's really where we are now. It's a very exciting time.
I have notes here that said, from earlier in your talking, we were talking about directionality with adults going towards children.
Yeah.
And my note says, why might it not be vice versa?
Children talking to adults or talking to children?
Yes.
That's such a great question. I think the reason people look so much at infant-directed speech is because it's such a stable, discrete category with so many measurable different acoustic features than adult-directed speech that it's just, there's a whole canon of work about that. I wonder, there probably is stuff about infant and adult-directed speech in children. I just don't know that literature, but I bet that it exists. Yeah.
Would you please give us some more words about how the brain listens and sometimes hears the music and sometimes hears the words, and what's going on in the brain? Because I've noticed that some people, when they listen to music, they're only hearing the words, and other people are only hearing the notes.
Yes. Yeah, okay, you are so right about that. It turns out it's a very durable individual trait whether you're a lyrics person or a notes person. So people who pay attention to and remember the lyrics, at time point now, if I come, measure you again a couple years later, you also are just like focusing on the lyrics when you listen to music, right? Whereas other people, like me, I really have this deficit where I just can love a song and someone points out the words and I'm like, oh, that's horrifying, I feel so bad. I really tend to pay attention to the notes. So that does seem to be an individual difference. And at the level of the brain, so if you think about auditory cortex in both hemispheres, one thing people originally got excited about is, oh, okay, it does seem like speech processing is left lateralized And music processing is happening more in the homologous region on the right side. Oh, maybe we have music-specific processing. But in fact, if you kind of do a bunch of studies to figure out what selectively activates the right side versus the left side, it tends to be just these exact features that I was listing about musical sound. So when the frequency is changing more slowly, even if it's noise, it's not music, that's more of a right hemisphere thing. But if it's really changing quite rapidly, like happens in speech, that's a left hemisphere thing. But because they're these kind of paired regions, I showed you a little bit about rhythmic auditory stimulation for gait. Another really well-researched clinical intervention using music harnesses the power of the auditory cortex that usually comes online to respond to music to help people who have aphasia. So an example of this is Gabby Giffords, who lost the ability to speak after she was shot, and used this kind of music-based therapy where she couldn't speak the words, but she could sing them, and then you gradually scaffold and take away the contour and make it more speech-like across the treatment.
I'm curious to know if you take the average user listening to, say, a piece of chamber music, and you did the studies to see where it was activating their brain, and you did the same thing to the performers, not while they're performing perhaps, but performing with different instruments. Have there been any studies to show that how different these are?
Yeah, oh, that's a really good question. So one study that we actually did, we used people, I was in Chicago then, and we used professional Chicagoan flute players and violinists. And we played them music. It was Bach solo music that we could play on flute, or excerpts of it for them on flute or on violin. So they were listening to either their timbre of expertise or the same kind of music, but for a different instrument. And what was that was matched differently for each of them, right? So the selective timbre of expertise is flute for the flautist and violin for the violinist. And we saw this lovely result where when people were listening to their timbre of expertise, all this kind of activity in motor regions that were specific to kind of finger control for their instrument emerged. You might experience this if you have been trained on an instrument that you kind of can't repress something about fingerings or something while you're listening. So I think that's one difference. But then there's a whole host of other, maybe more interesting differences. One thing we saw in our study is that brain areas that are more dedicated to self-relevance, like deciding when stimuli are really important to you, were selectively active for the timbre of expertise. But now there are these amazing labs. There's one in Hamilton, Ontario at McMaster University, and one in Frankfurt at the Max Planck Institute for Empirical Aesthetics, where it's a concert hall, but completely wired up to collect data. So there's eye tracking and EEG at every seat and for the performers. And one thing people get excited about with EEG in particular is looking at the way listeners synchronize and with performers while the concert's ongoing. So that's another, I think, really interesting development in our field, is just this kind of big data approach where you're looking across an entire concert at responses from many people. Thank you very much.